Hi, so today we're going to learn about the mean value theorem. So the mean value theorem basically states that if a function f of x is continuous on the closed interval ab, and if f of x is differentiable on the open interval ab, then the slope of the tangent line at least one point C on the graph is equal to the slope of the secant line between 2 points A and B. So essentially this is saying that the calculus slope at a point C is equal to the algebra slope between points A and B. So when you're solving a mean value theorem problem, you want to first make sure that the function is differentiable and the function is on a closed interval. You don't have to make sure that it's continuous, because if the function is differentiable, then it has to be continuous. So let's take a look at this graph. So we have a curve here, and let's say we have 2 points right about here. Let's say this point is A, and this point is B. So this would be A, comma, f of A, so would be the coordinate point. So now, if we draw a line connecting the 2 points, this will be the secant line between points A and B. Now, what the mean value theorem says is that there must be at least one point C on this graph where if we draw a tangent line at that point, it's going to be parallel to this secant line. So I would estimate that somewhere about here, there should be, if we draw the tangent line, it should be parallel to this secant line. So let's draw a tangent line. So that line is about parallel to the secant line. So we can call this point C. On this graph, there's another point C where it could be parallel to the tangent line. I would say it would be somewhere about here. So let's draw a tangent line at this point. And that's about parallel to that line. So we can also call this point C. So that's basically the mean value theorem. Now there's another theorem called Rolle's theorem that is very similar to the mean value theorem. It basically uses the mean value theorem to show, and it's basically a special case of the mean value theorem. So let's draw a graph first to understand what it is. Say we have a graph that looks something like this. And we pick 2 points on the graph. This is point A, this is point B, and we draw a line. So this is a horizontal line. So the special case that Rolle's theorem has is that f of A should equal f of B. So if the y values at points A and B are equal, then you can use the Rolle's theorem. Obviously, you want to still make sure that it's continuous and differentiable. So, same as the mean value theorem, you're going to write that the slope of the tangent line at a point C is equal to the slope of the secant line through points A and B. But now, since f of A equals f of B, if you subtract f of A from f of B, it's going to be equal to 0. So f prime of C basically equals 0. This is the special case of mean value theorem called Rolle's theorem. Okay, so now we're going to move on to an example. So for the first example, it says, for the following function, find the value of c such that the mean value theorem is satisfied. The function is f of x equals negative 2x cubed plus 6x minus 2. And the interval is negative 2 to 2. So first we want to make sure that it's a closed interval. Next we want to make sure that it's differentiable. So let's find the derivative first. Using the power rule, we find that the derivative of f of x is equal to negative 6x squared plus 6. So we know that the function is differentiable because the domain of the derivative is negative infinity to infinity. Next, we're going to solve for the two endpoint values. F of 2 is equal to, I'm just going to plug it into the function. And this is equal to negative 6. So next, we're going to plug this into the slope formula, f of b minus f of a over b minus a. And that would be negative 6 minus 2 over 2 minus negative 2, which is equal to negative 2. Our f prime of c equal to f of b minus f of a over b minus a, as in the mean value theorem. We know f of c, f prime of c is the derivative of the function, which is 6x squared plus 6 equals, and then we know the slope is negative 2, so negative 2. So x is equal to plus or minus 2 over root 3, which is equal to about plus or minus 1.155. So we want to make sure that this is in the closed interval negative 2 to 2, and it is. So that means both these values are valid. So x is basically c. So the values of c are negative 1.155 and positive 1.155. So one of the mistakes that people often make is when we're solving for f of a and f of b, people tend to plug the value into the derivative of f of x instead of the original function. So when we need to find values to plug into these, we have to plug the endpoints of the interval into the original function instead of the derivative. So that's one of the mistakes that people tend to make. Another possible mistake is that when you get the answer, you have to check if it's in the interval. If it's not in the interval, it's not a valid answer. For example, say we have an interval of 2 to 4, a closed interval of 2 to 4, and you get answers 2 and 5. 5 is not in the interval of 2 to 4, so 5 is not an answer. You can only say the answer is 2. So those are two mistakes that people tend to make. And that's it for this video. Thanks for watching. Hi, so today we're going to learn about the mean value theorem.